Okay, day one of application of derivatives. Let's look at this example. We have f of x is equal to x cubed minus 3 over 2x squared. And when is it increasing or decreasing? So we know that when the first derivative is positive, the function is increasing, and the first derivative is negative, the function is decreasing. So if f prime of x is positive, that means f is increasing. And when f prime of x is negative, f is decreasing. Okay, so let's find f of x, or f prime of x. F prime of x is, you take the derivative of this function, 3x squared minus 3x. And when you factor out 3x, you get x minus 1. Okay, so when is my f prime 0? Okay, you're looking at a zero product property, right? When is 3x 0? When x is 0. And when is x minus 1 equal to 0? When x is 1. So your critical numbers, that's when f of x is 0, okay, are x equals 0 and 1. So those are your critical numbers. So I'm going to make a number line. Okay. Alright, so I'm going to make a number line here. So hopefully it's going to be a straight line. Okay, so I just need to look at 0 and 1, because those are the only places when the increasing decreasing behavior will change. Alright, so if I plug in numbers less than 0 in f prime, and I'll get a increasing decreasing behavior, or at least a sign of f prime. Okay, so if I plug in negative number here, 3 times x is a negative number, and then x minus 1 is also negative, so negative times negative is going to be positive. Any number from between 0 and 1, that's going to be positive number here. 3 times x is positive, but x minus 1 is negative, so you will get a negative number here. And anything bigger than 1, you will get a positive value for f prime. So this means, if you look at the behavior of f, what's happening to f in those intervals, f is increasing here, decreasing here, and increasing there. Okay, so f is increasing when x is between negative infinity and 0, and anywhere from 1 to positive infinity. And you can, I think, you can write, x is less than 0 or greater than 1. F is decreasing when x is between 0 and 1. Yeah. So knowing this, now if you imagine a graph, right, that's increasing here, and then at x equals 0, there's f prime is 0, so that means that you're for the horizontal tangent, and then you go back down, and at 1, f prime is 0, and then you go back up. So you can use a first derivative test to figure out that, oh, there's a local maximum at x equals 0 and local minimum at x equals 1, right? Uh-oh, why is that moving? So here it says identify all local max and min for this function. Well, I know that before, to the left of x equals 0, the f is increasing, and to the right of x equals 0, the function is decreasing. So I have a local max at x equals 0. But to find the actual maximum value, you have to plug in the function here. So this is your maximum value, which is 0. And to cover all aspects, when you answer it, you can just write a coordinate, and that'll answer everything. So this is your local max is at 0, 0, and your local minimum at x equals 1. So what is f of 1? If you plug it in, 1 minus 3 over 2, that's going to be negative 1/2. So your local minimum is at 1, comma, negative 1/2.